Imagine a world where the tiniest particles hold the greatest secrets. Welcome to the fascinating journey of neutrons, the unsung heroes of the universe. Imagine a world without atoms. It's like trying to imagine a pizza without cheese. Impossible, right? Atoms are the fundamental building blocks of everything in the universe. From the air we breathe to the ground we walk on, everything is composed of atoms. They are the tiny units that come together to form molecules, which in turn make up the matter we interact with every day. Without atoms, the very fabric of our reality would cease to exist. But what makes up these atoms? What are the components that give atoms their unique properties and allow them to bond and interact in such complex ways? Atoms are the building blocks of everything we see and touch. They are composed of a nucleus, which contains protons and neutrons, and electrons that orbit this nucleus. The interactions between these subatomic particles give rise to the diverse materials and substances we encounter. From the hardness of a diamond to the fluidity of water, it's all due to the behavior of atoms and their components. But let's focus on one particular component of the atom that often doesn't get the spotlight it deserves, the neutron. But atoms themselves are built from even smaller particles. These subatomic particles include protons, neutrons, and electrons. While electrons are known for their role in chemical reactions and electricity, and protons are recognized for their positive charge, neutrons are equally crucial. They might not have an electric charge, but their presence is vital for the stability of the atom. Without neutrons, atoms would not hold together as they do, and the universe would be a very different place. One of these is the neutron, a tiny particle with a big role to play. Neutrons are found in the nucleus of an atom, right alongside protons. Despite being electrically neutral, they have a mass almost equal to that of protons. This mass is crucial because it helps to balance the forces within the nucleus, ensuring that atoms remain stable. Neutrons act as a kind of glue, holding the nucleus together and preventing it from breaking apart due to the repulsive forces between positively charged protons. Neutrons reside in the heart of the atom, in the dense nucleus. This central part of the atom is incredibly small compared to the overall size of the atom, but it contains nearly all of the atom's mass. The nucleus is where the protons and neutrons are tightly packed together, and the arrangement of these particles determines the identity and properties of the atom. The number of protons defines the element, while the number of neutrons can vary, leading to different isotopes of the same element. Unlike their positively charged counterparts, protons, neutrons carry no electric charge. This lack of charge means that neutrons do not repel each other or the protons in the nucleus, allowing them to act as a stabilizing force. This neutrality is essential for the balance within the nucleus, as it helps to mitigate the repulsive forces between the positively charged protons. Without neutrons, the nucleus would be unstable, and atoms would not be able to exist in their current form. They are the peacekeepers of the atom, essential for its stability and existence. Neutrons play a critical role in maintaining the delicate balance within the nucleus, ensuring that atoms remain intact. This stability is what allows atoms to form the complex structures and compounds that make up the world around us. From the simplest hydrogen atom to the heaviest elements, neutrons are a key component in the architecture of matter. Without neutrons, our universe would be a very different place. The stability provided by neutrons is what allows stars to shine and planets to form. In the absence of neutrons, the forces within atomic nuclei would be unbalanced, leading to the disintegration of atoms. This would result in a chaotic universe where the fundamental building blocks of matter could not exist in a stable form. The very processes that drive the formation of stars and planets would be disrupted, altering the course of cosmic evolution. Stars wouldn't shine, planets wouldn't form, and life itself wouldn't exist. The presence of neutrons is essential for the nuclear reactions that power stars, providing the energy that lights up the cosmos. Planets, which are formed from the remnants of these stellar processes, rely on stable atoms to build their structures, and life, in all its diversity, depends on the complex chemistry made possible by stable atoms. Neutrons, though often overlooked, are fundamental to the existence of everything we know. The neutron, though tiny and often overlooked, is a true unsung hero of the cosmos. Its role extends far beyond the confines of the atomic nucleus. Neutrons are involved in processes such as nuclear fusion and fission, which are responsible for the energy production in stars and the power of nuclear reactors. They also play a part in the synthesis of new elements in stars, contributing to the chemical diversity of the universe. The neutron's impact is vast and far-reaching, influencing both the microcosm of the atom and the macrocosm of the universe. So let's delve deeper into the world of the neutron, exploring its structure, its role in the atom, and its profound impact on the universe we call home. By understanding the neutron, we gain insight into the fundamental forces that shape our reality. We uncover the hidden mechanisms that govern the behavior of matter and the evolution of the cosmos. Join us as we embark on this journey to discover the secrets of the neutron, a tiny particle with a truly monumental role.
If you thought atoms were small, wait until you hear about quarks. These tiny particles are so minuscule that they make atoms look gigantic in comparison. Quarks are the fundamental constituents of matter, and they come in 6 different types, or flavors: up, down, charm, strange, top and bottom. But in everyday matter, we mostly encounter just the up and down quarks. Think of them as the vanilla and chocolate of the quark world. These minuscule particles are the building blocks of neutrons and protons. Neutrons and protons, in turn, make up the nuclei of atoms, which form the matter we see around us. Without quarks, there would be no protons or neutrons, and thus, no atoms, no molecules, and no life as we know it. So you could say quarks are the unsung heroes of the universe, like the backstage crew at a rock concert. A neutron is made up of 3 quarks, 2 down quarks and 1 up quark. Similarly, a proton is composed of 2 up quarks and 1 down quark. These combinations are held together by the strong force, which is one of the 4 fundamental forces in the universe. It's like a cosmic game of Twister, but with particles.
But what keeps these quarks together? The answer lies in the strong force, also known as the strong nuclear force. This force is incredibly powerful, much stronger than the electromagnetic force that holds electrons in orbit around the nucleus. Imagine it as the Hulk of forces, smashing everything else in comparison. Enter the strong force, one of the 4 fundamental forces in the universe. The other 3 are gravity, electromagnetism, and the weak force. Among these, the strong force is the most powerful, but it operates only over very short distances, on the order of the size of an atomic nucleus. It's like having a superpower that only works in your living room. The strong force acts like superglue, binding the quarks together incredibly tightly. This force is mediated by particles called gluons, which are exchanged between quarks, creating a strong attraction that holds them together. Think of gluons as the ultimate friendship bracelets for quarks. It's the strongest force we know of, but it only works over extremely short distances, like those within a neutron. Beyond these tiny distances, the strong force rapidly diminishes, which is why we don't feel it in our everyday lives. So no, you can't use it to fix your broken phone screen. Think of it like this. Imagine 3 grumpy cats, the quarks, constantly trying to escape from a small box, the neutron. The strong force is what keeps them confined within the box, preventing them from escaping. It's like the ultimate cat wrangling challenge. The strong force is like a powerful owner who keeps those cats in check. Without this force, the quarks would fly apart, and the neutron would cease to exist. This incredible force is essential for the stability of matter in the universe, making it a fundamental aspect of our existence. So, next time you see a cat, remember the quarks and the strong force keeping our universe together.
Now let's zoom out a bit and look at the atom as a whole. It's like zooming out on a chaotic family reunion. At the center of every atom lies the nucleus, a tiny, dense region containing protons and neutrons. Think of it as the VIP section of a very exclusive club.
Protons, with their positive charge, would normally repel each other, causing the nucleus to fly apart. It's like trying to keep 2 magnets with the same pole together. That's where neutrons come in. They're like the bouncers at this VIP club. Like skilled mediators, neutrons help to stabilize the nucleus by counteracting the electrostatic repulsion between protons. Think of them as the chill friends who keep everyone from fighting at the party. They act as a buffer, preventing the protons from getting too close and triggering a nuclear meltdown. It's like keeping your exes at opposite ends of the room.
Imagine a dance floor filled with people who can't stand each other. Awkward, right? The neutrons are like the peacekeepers who make sure everyone keeps their distance and avoids a brawl. They're the unsung heroes of the atomic world.
Neutrons are not just important for the stability of individual atoms, they are the glue that holds the atomic nucleus together. Without neutrons, the positively charged protons in the nucleus would repel each other like two magnets with the same pole, causing the nucleus to disintegrate faster than a sandcastle at high tide. This fundamental role of neutrons ensures that atoms remain intact, forming the building blocks of matter. Beyond their atomic role, neutrons are crucial for the existence of the universe as we know it. They are involved in processes that govern the life cycles of stars and the creation of elements. Without neutrons, the universe would be a vastly different place, devoid of the complex structures and life forms we see today. Imagine a universe without neutrons, like a pizza without cheese. Sure, it exists, but who would want it?
They play a vital role in nuclear reactions, which are the heart of stellar processes. In stars, nuclear reactions involve the fusion of lighter elements into heavier ones, releasing energy that powers the star. Neutrons are key players in these reactions, facilitating the fusion process and enabling the star to sustain its energy output over millions or even billions of years. Think of neutrons as the unsung chefs in a cosmic kitchen, whipping up elements like a master chef creating a gourmet meal. These nuclear processes not only power stars, but also create the elements that make up everything around us. From the carbon in our bodies to the oxygen we breathe, all these elements were forged in the hearts of stars through nuclear reactions involving neutrons. This stellar alchemy is responsible for the rich diversity of elements found in the universe. It's like a cosmic version of Chopped, where stars are the chefs and elements are the ingredients.
In the intense heat and pressure of a star's core, neutrons can fuse with protons to form heavier elements, a process that releases enormous amounts of energy. This fusion process is what keeps stars shining brightly in the night sky, providing light and warmth to their surrounding planets. It's like a cosmic bonfire, where neutrons are the logs keeping the fire burning. The energy released during these fusion reactions is immense, powering the star and enabling it to emit light and heat. This energy is essential for the star's longevity and stability, allowing it to shine for millions or even billions of years. Imagine if your car could run for 1 billion years on a single tank of gas. Now that's neutron efficiency.
This process, known as nuclear fusion, is what makes stars shine. It is the reason why stars are able to produce the light and heat that we observe from Earth. Without nuclear fusion, stars would not be able to sustain themselves, and the universe would be a much darker place. Imagine a universe without stars, like a party without music. Sure, it's still a party, but it's missing the vibe. The energy produced by nuclear fusion in stars, including our own sun, provides the energy for life on Earth. The sunlight that reaches our planet is a direct result of the nuclear fusion processes happening in the sun's core. This energy drives the Earth's climate and weather systems, supports photosynthesis in plants, and ultimately sustains all life forms. It's like the sun is our cosmic battery charger, keeping everything powered up and ready to go.
Neutrons are also essential for the dramatic death throes of massive stars, known as supernovas. When a massive star exhausts its nuclear fuel, it can no longer support itself against gravitational collapse. The core collapses, leading to a catastrophic explosion that outshines entire galaxies for a brief period. It's like the grand finale of a fireworks show, but on a cosmic scale.
When a star runs out of fuel, it collapses under its own gravity, compressing the core and forcing protons and electrons to combine and form neutrons. This collapse is so intense that it triggers a supernova explosion, dispersing elements into space and creating the conditions for new stars and planets to form. It's like the ultimate recycling program, turning old stars into new cosmic material. During this collapse, the core becomes incredibly dense, and the protons and electrons merge to form neutrons. This process results in the formation of a neutron star, an object so dense that a single teaspoon of its material would weigh billions of tons on Earth. Imagine trying to lift that with a spoon. Talk about a heavy meal.
This creates a neutron star, an incredibly dense object composed almost entirely of neutrons. Neutron stars are among the most extreme objects in the universe, with gravitational fields so strong that they can bend light and warp space-time. It's like the universe's version of a black hole's little sibling, still incredibly powerful but not quite as intimidating.
So, from the smallest atoms, where neutrons ensure stability and cohesion, to the largest stars, where they drive nuclear fusion and stellar evolution, neutrons play a fundamental role in shaping the universe we inhabit. Their presence and interactions are crucial for the formation of elements, the life cycles of stars, and the dynamic processes that govern the cosmos. Without neutrons, the universe would be a vastly different place, lacking the complexity and diversity that make it so fascinating. It's like a cosmic jigsaw puzzle, and neutrons are the pieces that hold it all together.
The neutron, a tiny particle residing in the heart of the atom, is a true unsung hero of the universe. It holds the nucleus together, enables stars to shine, and participates in the creation of elements. Without neutrons, the universe would be a vastly different place, a place without the building blocks of life as we know it. It's all for today, folks. Please consider subscribing and watch my next episode. Thank you and goodbye.